Something massive just got exposed. Not a data breach, not a Windows update going wrong. Something quieter, and in some ways more damaging than either of those things. A research team at the University of Chicago just published a peer-reviewed paper in one of the most credible scientific journals on the planet. And what it describes is a potential shortcut through the most expensive problem in the history of computing. The kind of shortcut that, if it scales, makes Microsoft's entire AI strategy look like a $100 billion bet placed on the wrong horse. And the deeper you look at this story, the more uncomfortable it gets for a company that has been asking users to trust it, pay more, and tolerate friction in exchange for an AI future that is not delivering what was promised. Let's start with the size of the bet, because without understanding the numbers, none of this lands the way it should. Microsoft has committed approximately $80 billion in fiscal year 2025 alone to build out AI-enabled data centers. That is not research money. That is not marketing spend. That is concrete, steel, power cables, cooling systems, and servers stacked across dozens of facilities around the world. And for fiscal year 2026, the number is being guided towards somewhere between $146 billion and $190 billion, up 61% year on year, while the flagship product that is supposed to justify this spending is underperforming in ways that are becoming impossible to ignore. For comparison, Microsoft's entire capital expenditure in 2020 was $17.6 billion. In 5 years, that number has grown by a factor of 10, and it is still accelerating. If you use a Windows computer, you have felt this strategy on your desktop. The Copilot key that appeared on new keyboards you did not ask to redesign. The sidebar that slides in uninvited. The AI summaries in Outlook that you did not request. The prompts that treat your own operating system like a product you are renting from a company that does not entirely trust you to make decisions for yourself. Every single one of those friction points is justified by the same argument. AI is expensive to build and expensive to run, and the cost gets passed on to users in the form of subscription price increases, mandatory integrations, and a Windows experience that increasingly resembles a platform designed around Microsoft's business model rather than around what users actually want. That assumption, that brute force compute scale is the permanent foundation of AI, is exactly what University of Chicago researchers just walked up and challenged with published, peer-reviewed mathematics. The paper is titled, "Towards Provably Efficient Quantum Algorithms for Large-Scale Machine Learning Models." It was published in Nature Communications, which is not a blog post or a preprint or a startup pitch deck. It is a peer-reviewed journal with serious credibility. The research was led by Professor Liang Jiang at UChicago's Pritzker School of Molecular Engineering, with collaborators from Argonne National Laboratory, UC Berkeley, MIT, Brandeis University, and Freie Universität Berlin. This was not one lab having a hunch. This was a serious multi-institutional research effort, producing provable algorithmic results. And what they showed is that quantum computing can be incorporated into the classical machine learning process to make it more efficient and more sustainable. Here is what that actually means in plain terms. Training an AI model, the kind that powers Copilot, requires months of computation running on thousands of GPUs consuming electricity at industrial scale. The process involves solving enormous mathematical equations, specifically the gradient descent equations that allow a model to learn from data. What the UChicago team showed is that a quantum processor injected into that process can handle some of the heaviest mathematical lifting in a way that classical processors cannot match. Less time, less power, fewer servers, less money. The paper describes end-to-end quantum machine learning algorithms that come with provable guarantees on efficiency, not just optimistic estimates. Co-author Professor Jens Eisert of Freie Universität Berlin put it directly. "We were surprised to see a lot of potential. We not only suggested the core idea, but went into painstaking detail of the scheme." The team's conclusion was blunt. Machine learning might possibly be one of the flag applications of quantum technology. To be honest about what this paper is and is not, it is important to say clearly that quantum computers are not replacing GPU farms tomorrow. The fault-tolerant quantum computers needed to run these algorithms at commercial scale do not exist yet as production hardware. This is a roadmap and a proof of concept, not a product launch. But it is a credible warning sign, published by serious researchers with no financial stake in making Microsoft look bad, And it challenges the core assumption that the only path to better AI is spending more money on more classical hardware. And this is where Microsoft's problem gets a lot more complicated, because Microsoft is not ignorant of any of this. Microsoft has been running its own quantum computing project for nearly 20 years. And in February 2025, the company unveiled what it called Majorana 1, described in official Microsoft communications as the world's first quantum chip powered by a topological core architecture. Microsoft's claim is that this chip, built around exotic particles called Majoranas, represents a fundamentally different approach to quantum computing, one that stores information in a way that is inherently more stable and less prone to errors than conventional qubit designs. The stated goal is eventually scaling to 1 million qubits on a single chip. Microsoft was also selected by DARPA as one of only 2 companies to advance to the final phase of its underexplored systems for utility-scale quantum computing program, which is not a minor footnote. That is government validation that Microsoft's approach is worth taking seriously. So here is the situation inside one company. Microsoft's classical AI team is spending $190 billion per year building data centers based on brute force GPU computing. Meanwhile, Microsoft's quantum team is working on a chip that, if it succeeds, could eventually make those same data centers less necessary. Both projects exist simultaneously, inside the same corporation, pulling in opposite directions. If the quantum bet eventually wins, it makes the classical bet look extravagant. Microsoft has been building both the bridge and the boat, and right now, neither one is done. But here is the catch, and this is the part that should make every investor and every user pay close attention. Microsoft's topological qubit claims have a credibility problem that has not gone away. After Microsoft's most recent Majorana chip update, announced at Microsoft Build, physicist Henry Legg of the University of St. Andrews was not impressed. His assessment, published in Science News, was unambiguous. Nothing in this preprint resolves the fundamental issues, and nothing in the presented data proves the existence of a topological qubit or Majoranas in these devices. The update involved swapping aluminum for topological qubit, lead as the superconductor in the chip's nanowires, which improved a metric called parity lifetime. But critics argue that Microsoft has still not convincingly demonstrated both of the measurement types needed to prove a functioning topological qubit exists. Some physicists see genuine progress. Kartik Agarwal of Argonne National Laboratory called one specific measurement result fantastic progress. But the scientific community is divided, and the field of topological quantum computing has a documented history of controversial claims and paper retractions that has made independent researchers demanding about what counts as proof. This is not Microsoft bashing. This is peer review, doing exactly what it is supposed to do. But it does mean that Microsoft's quantum bet, the one that is supposed to eventually justify the brute force classical spending by offering a smarter long-term path, is still unproven in the eyes of independent physicists. And a university lab in Chicago just published an open, freely available, peer-reviewed quantum AI shortcut that anyone in the world can read and build on, while Microsoft's own quantum research remains disputed. Meanwhile, the rest of the quantum world did not wait for Microsoft to figure out its credibility problem. In October 2025, Google demonstrated a 13,000 times speedup over the Frontier supercomputer, which is currently one of the most powerful classical supercomputers on Earth, using just 65 qubits on a quantum device running physics simulations. That is not a lab experiment with no real-world relevance. That is a concrete demonstration that quantum systems can outperform classical supercomputers by factors that are almost difficult to write down without stopping to reread the number. The quantum computing sector raised $3.77 billion in equity funding in the first 9 months of 2025 alone, nearly triple everything raised across all of 2024. The 2025 Nobel Prize in Physics was awarded for foundational work on superconducting quantum circuits, the technology underpinning Google's and IBM's quantum computers. Fred Chong, a computer science professor at the University of Chicago and a recognized authority in the field, described 2025 as very comfortably in the era of escape velocity for quantum error correction. At the International Conference on Quantum Engineering in 2025, Co-chair Francesco Campioli put the stakes in words that should appear on a wall inside every Microsoft data center planning meeting. It is the cost of energy that ultimately will define the cost of intelligence. That sentence is the entire argument in one line. If quantum efficiency wins, the company with the biggest pile of classical servers does not win the AI race. The company with the best algorithms wins. And algorithms, unlike data centers, can come from university labs. They can be published openly. They can be freely read and built upon by anyone. Now, take all of that and look at the product Microsoft is using to justify every bit of this spending. Look at Copilot. According to Recon Analytics data reported in early 2026, only 3.3% of Microsoft 365 commercial users who interact with Copilot actually pay for it. That is the paid conversion rate for what is supposed to be the centerpiece of Microsoft's AI consumer strategy. The accuracy net promoter score for Copilot sat at negative 19.8 inches January 2026. A negative NPS means more users actively distrust the product than trust it. And 44% of users who tried Copilot and then stopped cited distrust of its answers as their primary reason for leaving, a number that is higher than the equivalent churn figure for both Gemini and ChatGPT. Copilot's share of the paid AI subscriber market dropped from 18.8% in July 2025 to 11.5% in January 2026, a 39% contraction in 6 months, during which Microsoft was actively investing in enterprise distribution and deepening integrations. Gemini crossed Copilot in paid subscriber market share in late November 2025 and has continued moving upward. 15 million paid Copilot seats at roughly $30 per user per month generates approximately $5.4 billion in annual revenue. Set against $37.5 billion in a single quarter of infrastructure spending, the unit economics here are not a business yet. They are a proof of concept that has not proven itself. IT administrators in enterprise environments report being mandated to deploy Copilot and then watching their employees quietly not use it. Reddit communities for IT professionals have been filling with the same frustrated observation. The tool is there. It is pre-installed. It has its own keyboard key, and people are ignoring it. An ex-Microsoft executive named Matt Veloso stated publicly, in remarks reported by Windows Central, that Microsoft missed the internet wave, the mobile wave, and now it missed the AI wave. He added, "Not even 3% of paying Copilot users use it even when the distribution is pre-deployed right in their faces. That is not an outsider taking a shot at Microsoft. That is someone who worked inside the company saying out loud what users who have been ignoring the Copilot sidebar already feel. Microsoft forced Copilot into everything, and the people it was forced upon mostly said no thank you. The investors are noticing. Microsoft's stock fell somewhere between 23 and 25% in the first quarter of fiscal year 2026, putting it on track for its worst quarterly performance since the financial crisis of 2008. Bloomberg analyst Jonathan Kofsky of Janus Henderson suggested that rather than paying Microsoft, more customers may eventually choose AI startups like OpenAI or Anthropic directly, cutting Microsoft out of the transaction entirely. The concern is not only that Copilot is underperforming. The concern is that the AI agents being built by OpenAI, Anthropic, and others could eventually replace the Office 365 workflows that represent Microsoft's most stable revenue foundation, which would mean Microsoft is spending hundreds of billions of dollars building the compute infrastructure that its own future competitors are using to develop products that disrupt Microsoft's core business. Microsoft has also undergone what one analyst described as the 5th structural reorganization of its Copilot organization. That is not a sign of confident execution. That is a sign of repeated course corrections inside a product team that has not yet found the version of this thing that users actually want. The restructuring of OpenAI into a public benefit corporation means OpenAI can now use rival cloud infrastructure, which removes the Azure exclusivity that Microsoft relied on as a hedge against Copilot's commercial struggles. Forrester Research summarized the broader situation plainly. Billions are flowing into AI supply-side capacity, while enterprise demand remains disciplined, governed, and conditional. Now go back to the University of Chicago research and think about what it actually threatens. The U-Chicago paper states clearly that fault-tolerant quantum algorithms could potentially contribute to most state-of-the-art, large-scale machine learning problems. Not some. Most. A European Union white paper on quantum and AI, published in March 2025, noted that the fine-tuning and distillation phases of AI training, where models are refined and compressed after initial training, could see quantum enhancements sooner than other phases, because those steps sometimes require only 10 to 100 data samples, rather than massive datasets. That matters because fine-tuning is where a lot of the ongoing cost and time in AI development lies. Rand Corporation projections suggest AI data centers could need 68 gigawatts of power capacity by 2027, which is close to the entire current power capacity of the state of California. Without efficiency breakthroughs, the Department of Energy has warned that AI power demands could require dozens of new power plants within the decade. Training a single large language model has been shown to produce 626,000 pounds of carbon dioxide, roughly equal to 5 cars' lifetime emissions, according to published University of Massachusetts research. The quantum shortcut being researched at places like U-Chicago is not just about saving Microsoft money. It is about whether the entire AI industry's current energy and cost trajectory is sustainable at all. If quantum algorithms can compress training costs radically, then Microsoft's competitive advantage, which is essentially a willingness to outspend everyone else, stops being an advantage. The company with the best quantum classical hybrid algorithms wins. That is not guaranteed to be Microsoft. It might be Google, which already demonstrated the 13,000 times speedup. It might be IBM, which is targeting quantum advantage in 2026. It might come from exactly the kind of open university research that U-Chicago published in Nature Communications, available to any researcher anywhere in the world for free. The U-Chicago paper is peer-reviewed. It comes with provable guarantees. It was written by academics with no incentive to embarrass Microsoft and every incentive to get the science right. Open source and academic communities have noted what many in the tech world already understand, that research like this, publicly available, freely readable, produced without subscription fees, represents a fundamentally different model of progress than what Microsoft is building. Microsoft's AI is proprietary, cloud-locked, subscription-dependent, and underperforming. The quantum shortcut is published, free, and honest about what it can and cannot do. This is the pattern that repeats in the history of computing, and it never ends well for the company that chose scale over smarts. IBM dominated mainframes and missed the personal computer. Microsoft dominated personal computers and missed the smartphone. Nokia dominated mobile phones and missed the app era. In each case, the company that won the previous era assumed the next era would reward the same strategy, just bigger and more expensive. Microsoft's Copilot bet is the argument that the AI era will look like the cloud era. More infrastructure, more subscriptions, more lock-in, more scale. The U-Chicago quantum research is one signal among many that the AI era might look fundamentally different, not bigger, smarter. Microsoft has spent nearly 20 years building a quantum computer in a research lab and $190 billion per year building data centers in the real world. The quantum computer is still disputed by independent physicists. The data centers are real, enormous, and producing a flagship AI product that 96.7% of the users it was forced upon are choosing not to pay for. The Chicago Quantum Exchange, which is where the U-Chicago Quantum AI research lives, is partnered with Argonne National Laboratory, Fermilab, and IBM. The researchers at that exchange are not building a product to compete with Copilot. They are building the mathematics that could eventually make Copilot's entire cost structure look like an artifact of a computing era that is already ending. The real question is not whether the University of Chicago researchers found a quantum shortcut. They published the math. It is there. Anyone can read it. The real question is whether a company that has spent $190 billion per year betting everything on brute force classical compute is even capable of noticing when the direction of travel changes beneath it. And the deeper question, the one that matters to every person who has a Copilot key on their keyboard they didn't want, a subscription price that went up for an AI feature they don't use, or a Windows experience that feels less like their computer every year, is this. Why does it take a university lab publishing open research to challenge assumptions that Microsoft's own users have been expressing through a 19.8 accuracy score, a 3.3% paid conversion rate, and the quiet, daily act of simply not clicking on the sidebar?